Today, we are diving into the factory of the future and a massive energy puzzle that comes with it. We're going to explore a brand new idea that pulls together robotics, AI, and renewable energy to solve it. It's a concept they're calling grid to robot. So here's the thing. Smart factories, these super automated, intelligent production lines, they're absolutely the future. They're faster, they're way more precise, but all that amazing tech brings up one giant question. How in the world do we power all of it without wrecking the planet? And that is the exact problem we're going to unpack today. All right, first up, let's really dig into what's being called the smart factories dilemma, because it's one of those classic situations where a brilliant solution ends up creating a whole new kind of problem. So, what even is a smart factory? Well, just picture a normal factory, but then pack it with all the latest and greatest digital tech. We're talking artificial intelligence, an Internet of Things where every single machine is connected, and of course, a whole fleet of advanced robots, all working together perfectly. The result is this hyper-efficient, incredibly intelligent system. And here's the catch. All of that incredible technology, the robots, the thousands of sensors, the massive computers processing all that data, it has a huge appetite for energy. So while we're getting way more efficient at making things, we're also running the risk of massively blowing up the carbon footprint for the entire industry. Now, you might be thinking, well, the answer's obvious. Just use renewable energy. But as it turns out, that's not a simple plug-and-play solution. It actually creates its own really complex puzzle. I mean, just look at this. A modern factory trying to be sustainable is a pretty complex beast. It's got to pull power from the main grid, from its own solar panels on the roof, and from big battery storage systems. Now, imagine trying to juggle all of those sources in real time to power a whole line of demanding robots. It's an insane management challenge. And let's break down exactly why it's so tricky. First, solar power comes and goes, right? You've got it during the day, but it's gone at night or on a cloudy day. Second, the amount of power a team of robots needs is just all over the place. It fluctuates wildly, and it's almost impossible to predict. So trying to balance the grid, the sun, and the batteries, second by second, it's a task that's way too complex for any simple controller. So, staring down this massive puzzle, the researchers behind this study came up with a really groundbreaking solution, a whole new way of thinking that they call grid to robot. And I want to be really clear, this is not just some small improvement on an old idea. The paper literally says this is the very first time the concept of G2R has ever been introduced. So we're looking at the birth of a whole new way to think about industrial power. So what is grid to robot? Well, you can think of it as a framework that does two things really, really well. First, it deeply connects the robots with all the different power sources. But the secret sauce, the second part, is that it uses a sophisticated AI to be the brain of the whole system, making smart decisions and coordinating everything in real time. And to prove this idea could actually work, the researchers built a simulation with 10 of these highly sophisticated robotic arms. These are what's known as 6 degrees of freedom robots, which basically means they can move and twist in any direction, a lot like a human arm. And all that complexity makes trying to predict their power needs a major challenge. So how does this AI brain actually work? How does it manage this incredibly complex dance between power supply and demand? Let's take a look under the hood. The researchers came up with this really clever two-step AI brain. The first part is called the generator, and its only job is to create massive amounts of super realistic but totally synthetic data about how these robots use power. Then, the second part, the predictor, takes all that rich data and uses it to learn how to forecast the factory's real power needs with incredible accuracy. Here's a great way to think about how that data generator works. It's a model called a WGANGP, and it's basically a game between an art forger and an art critic. The forger AI creates fake robot power data, and the critic AI tries to spot the fakes. They go back and forth, and in the process, they both get better and better, until the forger is creating data that's so realistic, it's perfect for training. The predictor AI, the one that does the forecasting, is a model called a ResNet, and it has this really clever trick up its sleeve. It uses something called skip connections, which act like information superhighways inside the network. They let the AI learn these incredibly complex patterns much, much faster by allowing important data to kind of jump the line, making sure nothing important gets lost along the way. Okay, so the theory is fantastic. The AI architecture is brilliant.
But does it actually work? It was time to see how the system performed when they really put it to the test. The results were, well, they were pretty incredible. The model achieved an accuracy score of 99.98%. To put that in perspective, it means it could predict the robot's crazy, fluctuating power needs with near-perfect precision. That's not just good, that is absolutely extraordinary. And here is the visual proof. What you're looking at is a plot of the model's predictions against the actual real-world data. Each one of those dots represents a moment in time. The fact that they form an almost perfectly straight line tells you that what the AI thought was going to happen was almost exactly what actually happened. It's a near-perfect match.
So how on earth did it get so accurate? Well, the AI learned to figure out what was most important. This chart shows us which factors had the biggest impact on its predictions. It learned that things like the torque on a specific joint or the angle of another were the critical clues to predicting power use. It's not just guessing, it's learning the underlying physics of the entire system. So let's zoom out. What does this all really mean for the future? Well, for starters, this grid-to-robot concept gives us an intelligent, automatic way to manage power in smart factories. It makes using renewables like solar way more practical and reliable for industry. And that, of course, leads to a smaller carbon footprint and lower operational costs. It is a huge foundational step towards what we could call truly smart, sustainable manufacturing. And that brings us to one final, really big thought. This research gives us an amazing blueprint for making a single factory sustainable. But it begs a much bigger question. If AI can optimize the carbon footprint of one incredibly complex system this precisely, what happens when we start applying the same kind of thinking to our power grids, our cities, or even our entire global supply chains? That's the exciting future this kind of work is pointing us towards.